Hello everyone, welcome to our presentation and our innovative greenhouse automation system. And this is our project. It utilizes 3 key sensors and actuator to maintain the optimal condition for the plant growth and enhancing the sustainability and efficiency in agriculture operation. We will walk through how it works, its benefits, and why it's a game changer for the modern farming.
Hello everyone, my name is Ari Komara
and my name is Hari.
and we are here to present about the electronics and circuitry of our smart greenhouse project. So before I explain the circuitry, let me explain the 3 main sensors and the 3 actuators connected to it. So we have 3 sensors that are used in our project. The first is air quality sensor. This air quality sensor is connected to this fan. The second sensor is soil moisture sensor that's in the soil now. This soil moisture sensor controls the pump for the water. And the third is the humidity sensor. The humidity sensor is in there and it controls the servo motor that opens and closes this flap. So now I would like to explain the circuitry. So if you come closer here, you can see that we are using Arduino for our project. So for the air quality sensor, we are connecting it to digital pin output A0, and it's also powered by the Arduino, which is going to be powered by our laptop for the demonstration purpose. So the second sensor, which is the soil moisture sensor, is connected to pin A1 and is also powered by the Arduino, and you can see this Arduino powers the positive and negative rails here. And finally, for the humidity sensor, we connected it to pin A2 and it's also connected and it's also powered by the Arduino. So I have explained to you about how the sensors are connected, and now Hari will explain how the relay is connected to the actuators.
So out of 3 of the actuators, only 2 of the actuators need the relay, which is the fan as well as the pump. So we use 2 relays, and both these relays are positioned in a normally open configuration, so that when an input is given, it will be normally closed. And then the circuit is complete, and the fan and the pump will start running. And so the fan and the pump is powered by this 9-volt battery through a series of potentiometer, which outputs around 4.5 to 5 volts, which is the rating for the pump as well as the fan. So now, as the fan is here, and the fan is connected to the digital output of pin number 4, and the pump is connected to the digital output of pin number 2. So now let's look into the servo motor. So the servo motor does not require a relay and is directly powered by the Arduino Uno itself. And its analog, digital output is connected to pin number 10. So that's about it on the relay side. I think that's all for the components. Thank you. Okay.
Hello, I will be explaining for the humidity sensor part. As you all know, humidity is very vital for us to keep a good environment for our plants. So the humidity in the greenhouse, in the smart greenhouse, will eventually keep increasing or decreasing depending on the type of situations. So that's why we have the humidity sensor attached to the behind side of the wall. When the humidity level drops below 40, then the humidity sensor will detect, and then when it's connected to the flap will open. Hence, the humidity inside the greenhouse will go up to the flap. But there is also a drawback that can happen in this situation, which is to neutralize the humidity, the outer air will come inside through the flap just to make the humidity normal again. But on the other hand, it will also have contaminants inside the greenhouse. So to manage the problem, it will be fixed by the filtration system in the next sensor. Thank you.
Hello, I'm here to explain about the air quality sensor and its application for this smart greenhouse. Here, we have air quality sensor, which is the actuator, is the fan. The function for this air quality sensor is to make sure the environment for this smart greenhouse is clean. As Saddam said, the air from outside will flow into this smart greenhouse through the hole, through the fan, and the environment in this smart greenhouse will be bad and full of bacteria. The air quality sensor will detect the air, which is the range of more than 215, and the fan will switch on and blow out the air and make sure the environment is clean. On the other hand, at the night, the aloe vera will emit the carbon dioxide, and the oxygen inside this smart greenhouse will be low, and the air quality sensor will detect it, and the fan will blow out the carbon dioxide and make sure this environment is clean. So that's all. Thank you.
Hello everyone, my name is Muhammad Sabri, and so I'll be explaining our first sensor here, the soil moisture sensor. So the soil moisture sensor is going to measure the level of water inside the soil, and then according to our preset threshold, as you can see, it's going to turn on the water pump and take water from our reservoir and irrigate the plant. So as you can see here, over here, we have perforated holes in our tube, so it can distribute the water evenly throughout the soil. So this method ensures that it's automated, as well as not underwatering or overwatering our plant. One potential drawback, as you can see, is the reservoir we have. You need to have it properly managed so that the water does not run out, but this can be prevented easily by having scheduled maintenance. But other than that, the process is fully automated and allows the plant to be always watered for the perfect level.
Hi, so now I'm going to explain we are going to explain the sustainability aspect of our project. So as you can see here, we are going to be using this solar panel, and the circuitry is going to be explained by Ari now.
So if you can come to the back of the project here, you can see that this solar panel is soldered on, the wires are soldered onto the solar panel, and is connected to a DC booster module, which also acts as a charge controller. So what it does is it regulates the voltage and also boosts the DC voltage so that it can power the relays of our smart greenhouse system.
So right now, it'll only work when there is sunlight. So we do have a backup battery to power the relay system when there's no sunlight. But in the future, we are planning to incorporate the solar panel to charge some rechargeable batteries. So we would not need the backup battery supply. That's all for the sustainability aspect. Thank you.
Thank you.